everybody. Good to see you. Glad to be here right now. My name is Alex Perkins. I am from Nantucket, Massachusetts, and currently live in Vermont right now. My background is in engineering, and I've been involved with a few different kinds of projects related to the blue economy and sustainability. I'm going to be taking a little bit of time just to share them with you. 10 years ago, I first got involved with the Stone Soup Institute when I was part of a project that helped get a wind turbine up at my high school. And so I was at the summit speaking about 10 years ago now, and I'm excited to be back here again. So I'll get to all of that, and I'll just kind of walk you through. I've got a little presentation set up. Can I share my screen with you? Is that possible, Trevor? So, engineering climate solutions in the blue economy and beyond. Yeah, let's see. So, like I said, I'm from Nantucket. This is my home. This is a beautiful satellite photo taken of it, and it just goes to show how small it is, but also how connected locals are with the ocean. This is it right here. Growing up on a small island like this really is what gave me an appreciation for the environment, for the ocean, and for sustainability. So here's a picture that I like of myself, and I think that's my brother in the background. Got some masks on with a bucket on a boogie board. We're just looking for critters in the water to make a little aquarium. This is how I grew up, and my parents also helped further my love for the environment with their company, Shearwater Excursions. It's another, it's an ecotourism company. And ecotourism, I know you guys are talking a lot about ocean engineering and offshore wind and all that, but ecotourism is a whole nother realm within this blue economy. And so they started this business, and I grew up helping them. And it's pretty great because it has come full circle where we're able to take clients out and show them the natural side of Nantucket. This is me on, this is a clamming trip we do. We take families out, teach them how to dig for clams, and we also show the kids all the little critters that you can pick up in the tidal flats there. Again, growing up on an island surrounded by water, this is me probably the first time learning how to drive a boat. Was also able to eventually use that to get my captain's license and be able to show individuals, show kids how to drive and really give them these unique experiences that I was able to get to try to foster that creative, that love for the environment, because it's all about education. So other projects, when I was in high school, I got involved with a team where we helped to implement a 100 kilowatt wind turbine at our high school. And it was a huge undertaking. It took a lot of people with a lot of different backgrounds to get this done. And it was really eye-opening for me to be a high school student on this team with leaders from all these different organizations to see the full picture of what it actually takes to get a turbine up. And it's not as simple or straightforward as it seems. It was this huge, huge undertaking. So first and foremost, you need a funder. You need to be able to pay for the initial startup cost of the turbine. And then you need to do feasibility studies. And this was a huge project, and there were so many moving pieces to it. And it wasn't quite a linear process where you study one thing and then the next thing and then the next thing. They all kind of interact with each other. And then if something doesn't work, then you kind of have to loop back and check something else. So more or less, you start looking at different sites of where you want to install a wind turbine. And you have to weigh all the pros and cons of certain sites. You have to do a wind resource study. How much wind is actually blowing? How much, what wind speed is the turbine rated for? Yes, wind turbines are great. It's a renewable alternative energy future, but you do need to do environmental impact studies. And that's very important because you see a lot of opponents of wind, and especially offshore wind, that will actually cite that construction can cause harm. So you just have to, you really got to jump through the hoops to make sure you're able to check all the boxes and make sure that you minimize any kind of environmental risk as much as possible. This is probably more important for onshore winds than offshore winds, but we actually did study, did an acoustic study and also a shadow flicker study to figure out what buildings nearby are going to be affected, especially a wind turbine at a high school in such a densely populated area. The shadow will fall, and it's a moving shadow, so it's definitely something to come in mind. And then if something doesn't work out, then you kind of have to go back to the beginning. Okay, a wind turbine at this site causes a shadow on this house or at this school, so maybe we try a different site. Other things you have to look at, of course, electrical interconnection. You have to make sure that where you put the turbine, the electrical grid, the infrastructure, the school, our high school in this case, is well equipped to handle that increase in power. Also, other things that I had no idea about, geotechnical testing. What is that? You just have to make sure the soil underneath the wind turbine can support the load of the turbine. And perhaps one of the most important things is a financial analysis. Is a wind turbine worth it in the long run? You know, it costs, in our case, over $500,000 all in to get the wind turbine up. And we did a financial analysis to show it would pay for itself in about 10 to 12 years. So that's actually within the next year or two from now that the turbine will pay itself off. And then it's essentially generating free electricity after that. And then other things such as construction logistics, which is a huge part of it too. You have to be able to get these massive towers and blades from the manufacturer to the location, or if it's an offshore winds project, the port has to be able to handle these components. And in our case, Nantucket has lots of small streets that you have to be able to navigate these large blades around. Once you do all that, then you can go on to permitting, which is a blast. You have to jump through all the hoops of federal agencies. FAA, the Aviation Administration, has to check it off that it's not going to interfere with planes. The EPA, any kind of state bodies, and then in our case, you got to go through zoning and a zoning board, the HDC on Nantucket. And you have to talk to your utility company, in our case, National Grid. You have to get them on board. They have to be able to know that this is a plan. And in a lot of cases, you have to get what's called a power purchase agreement. If you build massive wind turbines, and especially a farm of them, you want to get in writing beforehand that someone is going to be buying that electricity from you. So huge process. Very, very interesting to be a part of, and very rewarding too, especially when you get final approval and get to install the turbine. This is a picture of me and my friend Will, who also went to the Stone Soup Summit 9 years ago now. And I'd just like to highlight again how it's a team effort, from working with the funder who provides the money to the owner of the property that the turbine's on. You're in constant communication with the wind turbine manufacturer, the utility company. And then in our case, as students, our primary role was in public outreach. So especially these days, false information and false narratives travel very quickly, almost at the speed of light online. So you really have to have the facts and be in constant communication with the manufacturer. So if somebody is concerned about how a turbine will impact them in their community, you can have hard data from the manufacturer, or go back to your feasibility studies to say, actually, this is the case. Yes, I'm glad you brought that up, but we studied it and boom, this is the way it is. And then you need consultants to help you with these feasibility studies, and an entire legal department. So it's a whole lot, but a very rewarding process. So that was in high school. After that, I went and studied engineering at the University of Vermont, and I was lucky enough to begin working for an organization in the Bahamas called the Center for Sustainable Development. CSD is committed to ensuring that to answering the question, how do you live well in the place, to ensuring that their community lives as sustainable as possible. So I was very excited to work for an organization like that, but also to be moving to the Bahamas. I thought I was very lucky to be on a beautiful, crystal clear Bahamian beach. But when I got there, I was a little taken aback that this was often the sight that you see on a beach like that. A lot of the beaches you see by resorts, they have to go out and pick plastic nearly every single morning off the beach. And that's because small islands like that, it's difficult to have any kind of recycling infrastructure in them. It's a small community, small population, so relatively little amount of waste being generated that you need to make a massive recycling plant worth it. So this was a pretty big eye-opener for me. And then the other thing that I thought was a big eye-opener was, even though this organization was in the Bahamas and it has an unimaginable sun resource, this is how 99.9% of the electricity is generated on the islands. These are big diesel generators burning heavy fuel oil 24/7 to be able to power the island. So these two things kind of stuck with me. And then in talking with my team down there, we came up with an idea. So I was part of a research and development project where we looked at plastic pyrolysis. I'll explain what pyrolysis is in a second, but basically, if you start with a water bottle, you drink the water, and then you're left with the bottle, a lot of time, pretty much all the time, what happens down there is the bottle is landfilled. And when I say landfilled, normally landfills have, it's called a liner underneath to prevent any kind of leachate, it's called, microfibers, plastic leachate essentially for going into the groundwater or the environment. But down there, it's pretty much just a pit. And when the pit gets too full, they just light it on fire. So landfill fires, like the one seen in this picture, is a pretty common sight, unfortunately. And that thick black smoke is no good. Lots of toxic chemicals going. So what my team and I thought was, okay, there has to be a better way. And we looked into pyrolysis. So pyro meaning heat, and lysis means to separate or break apart. We tried to reverse engineer plastic essentially, where plastic, it's actually made from petroleum. It's a petroleum derivative. So what we figured out is, okay, if plastic is taken out of the ground and if petroleum is taken out of the ground and turned into plastic, what if there's a way to take that plastic and turn it back into petroleum? And it turns out there is, through pyrolysis, essentially the thermal decomposition of a matter. So we were able to build a small scale reaction vessel, designed, built, test, and rebuilt it numerous times. And we were able to run an engine off of plastic derived fuel, which was huge success for not only us, but think of the implications worldwide. How many, literally millions and millions of tons of plastic are just sitting in a landfill right now. That's fuel that we can utilize to turn into money, essentially. It's turning a zero value product into a value added product. So I'd like to take a second and talk about what I'm up to now. Now, after that project, I moved up to Vermont and accepted a job working for a startup company called Synticos. This company is in the manufacturing industry, and we make these things here called abrasive water jet cutters. They're a common shape cutting tool in the manufacturing industry. It's basically a computer that shoots water, a mixture of water and sand, really fast out of a thin nozzle, and you can cut very intricate parts. I've got a few examples right here. You're really not limited to the kind of complexity that you can have. So cool to be a part of, except a big problem with this industry is the sand, the abrasive. So it's conventionally with these abrasive water jet cutters, you can only use the abrasive once. So the sand is mined out of the ground, shipped to a refinery where they make it the exact specifications that you need, and then shipped to the manufacturer that's actually using it. So that's not sustainable because you can only use that abrasive once, and then you have to actually pay to ship it away. And they're a huge headache. Machine operators don't like it because they have to deal with these bags of the abrasive that are used. They could only use it once, so they're just kind of sitting there. They're leaking all over the place. Huge, huge problem. So what we're trying to figure out is there has to be a way to be able to take that abrasive, develop some kind of recycling system so that we can take the abrasive, get it back to its proper specification, and then put it back into that nozzle there. And so that's what we're working on with this machine right here. This is a prototype, our almost finished beta system that is able to fully recycle abrasive used in these abrasive water jet cutters. And so this is just absolutely huge. Typically, manufacturers use a pound of abrasive per minute. So just extrapolate that out for one shop year round, how many hundreds and thousands of pounds they're going through, not to mention the entire industry. So it's something we're very excited about and nearing completion to getting a completed beta system in the field. So yeah, those that's just a quick little intro into a couple of the projects I've been working on. Excited to talk about all of them and share with you guys. And yeah, happy to take any questions that you might have.